practice. It's going to, teach you or tells you about your patient's care, the quality of services that you're providing. So this is, it involves a mathematical kind of, rigorous statistical review take place when you analyze your data. It's another important factor, the statistical review as a standard component of manuscript evaluation for publications. This is very, very important. When you submit a paper, not only, you have done under collected more than 1,000 or 2,000 samples, but when you employed a wrong or, improper statistical tools, your your manuscript or your study may not going to get published in a best journal or in a good journal. So every reviewers or peer reviewed journals also, or looking for to evaluate your statistical tool that you are employed. So the statistical reviews as a standard components of manuscript evaluations for publications. So don't take it very lightly when you are proposing or developing your your study. So make sure that you are use appropriate statistical tool for your study for good publications. So, what are the common pitfalls that we may encounter during, in the statistical analysis and presentations? So, the common pitfall where we encounter is when you design your studies, and when second one is you're presenting your data. Third one is a graphical comparisons and statistical analysis. So, these are these common, place where you commonly commit problems. First one is the designing studies. When you design a study, the investigator, the principal investigator should pay careful attention to the control groups. The control groups very, very important. Usually what we do compare, case control study, compare your study with your experimental design with already published data. Support sounds add sound value to your study. So you should have a control group which is parallelly to your experimental data. The second one is the randomization procedure, blinding and replications, how many times you're going to apply your interventions. Whereas the blinding, in RCT we have a single blind, double blind. This is how your assessments is blinded from you from your different groups. For example, if you are a single physiotherapist, want to give assessment to the patient, assess the patients, the same physiotherapist doing the intervention as well. So that will create kind of a biasness in the your data collections. And also what kind of randomization procedure that you use, what are the randomization procedure that you're going to use to allocate your samples in the different arms or different groups. You should be very careful in this so that you can produce a very valid kind of design that we employ in your study. So basically its a goal is to ensure the bias, that is a systematic errors, and also confounding factors. Things to be needs to be controlled not to produce a very valid estimate on the effect of your research or your interventions. Presenting your data always it's a issue. What I observed, when we read through master's dissertations, even PhD dissertations, they have problem in presenting the data. I think one student presented is intervention data between the groups in a tabular forms. The same data he wants to present in a graphical form. I think which is not correct. So we should use, you should choose according to your data type and what you want to, your study design. So this you should be keeping in mind. You should, take appropriate method in which you can present your data. So first things, in order to present your data, you're presenting your data, your sample size, it should be provide a true size of your sample size. Okay, so what happens, when you want to have a two groups, control groups and the experimental group, you should have your true sample size of each groups, right? So that's very, very important. You should describe your sample size. Second, what is the problem? What we commonly we see this, n equal to, for example, n equal to 5 to 12. So sample size can never be, presented as a range. It does not have any statistical significance. So sample size should not be presented as a range. It should be avoided. And also, as I said, it should be, you should provide, you should mention exact number of, sample size in each group should be mentioned in your presentation, in your manuscript or your dissertations. Descriptive of your data, the descriptive statistic should be provided. Okay, of a for your study of your study. Actually, let us see this table. Right, so this table has got three groups, right? So the baseline data needs to be described at the most, especially when you are doing, your comparative study. For example, groups. For example, I want to study about the ultrasound on tennis elbow along with, say, like a Mulligan mobilizations. Okay, so it's a one group having an ultrasound with the Mulligan mobilizations. That's your experimental, your control groups, or another group where you just use your Mulligan mobilizations. So in order to, differentiate, in order to provide the baseline data, each participant should be, described. You can use this mean and standard deviations. And also we have different, since it has got two different groups, you can this independent t-test for this to get the p-value. So this is quite often our physiotherapists, our literatures, we just ignore. We are not, putting more significant on this, providing this, the differences of p-value, because this is very, very important, especially when you compare your interventions with the against the gold standard, or against the control group. You should have the homogeneous populations. If you don't have homogeneous populations, you may not able to compare, your results, because you're comparing with apple to apple, where you are comparing with the apple to orange, right? So that is, we must be understand, you should have a detailed description of your baseline data, the mean and standard deviation if it is a continuous variables, and you should have, the group difference through p-values. So this is how you describe in your data. Suppose if your data is not normally distributed, or if for a very extreme data, you may use, median and interquartile range, right? So this is another thing. Usually, if the data is normally distributed, uses mean and standard deviation. Where it is not normally distributed, use median and interquartile range. So interquartile range is it's the quartile 3 minus quartile 1. So you'll get the median was 122.5. Quartile 1 is 25% of your data, and quartile 3 it's the 75% of your data. So it is interquartile q q3 minus q1. So you get the 40. So what is this? Trying to say here, if your data is not normally distributed, use median and interquartile range. The second one is, when you compare your data, you compare your interventions between the groups or among the groups. So you must use mean and standard error, because what we oftenly see in your clinical, your way you write your dissertation, your capstone, you usually write standard deviations. Okay, the actually standard deviation we should not use. If it is a continuous variable, you must use mean and standard error, not standard deviations. Why? Because the standard deviation describes the variability in the measures among experimental unit. For example, how this individual mean is deviate from your sample mean, right? So that is your standard deviation, dispersions within the mean. So whereas the standard deviation overall, represent variability in estimates. It's the mean estimations comparison with your population mean. How your mean of your group or sample variations with your sample mean. So what is the very important thing what we need to understand here, when you comparing two groups, we must use mean and standard error for continuous variable, not the standard deviations. Whereas when you're comparing again, but it is the binary variables, yes or no, you can use, yes or no using percentage, and categorical variables. Again, you can use frequencies, and also you have use a frequency, relative frequency can be used. I think it's very, very important. If you have very few responses, suppose you have only less than 50 or 60 responses, it's better to put it in a tabular form rather than displaying in a graphical forms. If you have a low response or samples that you want, when you are assessed, so it's better to use in tabular form as compared with your graphical form. Okay, so this is the data presentation with the binary and categorical variables. Okay, let us, in a nutshell, for the first goal, if you see this table, it is provides the what kind of the descriptive statistic we should use. For example, the first one describe the distribution of observation measured in the study samples. There's a baseline data like for the continuous variable,